I first started setting up this problem, I set it up like so. I said average, and I was like, oh, well, I'm going to use this. I'm going to use A is the integral from 0 to 30 of 1 over 30 A of t dt. Did anybody else set it up like that? That's not what we want to do. I set it up, and I was like, wait a minute, I don't think that this is right. And here's the key. I want you to focus on these terms. Average rate of change, okay, and average amount of grass clippings. Do you see those two phrases? They are distinctly different. Average rate of change, slope, derivative. That's what you want to think. Average amount, that's where we do the average value piece, okay? See the difference? Average amount is an average value. That's where you do this. This, average rate of change. If you got fooled by that, don't feel bad. I made the first mistake when I went through it, and I caught myself. I was like, okay, I'm going to go back. I think I know the right way to do this. So, yes, question. Oh, that's right. So, let's take out our calculator. We type in the function. Going to y equals, and it's 6.687 times 0.931 to the x power. That's what we want to have for function. And what we're going to do is, in order to find the average rate of change, we're going to find a of 30 minus a of 0 divided by 30 minus 0. That's the average rate of change. How do I calculate a of 30? So I can calculate, make sure that your window has what for an x value? Something at least 30 or bigger. So I chose 40 so I could see everything. So now as I look at the graph, you can see that I see from 0 to 40, and if we calculate a value, number one, we want to calculate at 30. And when we do that, we get 0.7829. And if I calculate at 0, the value at 0, I get 6.687. I divide that by 30. So 0.78292787 minus 6.687. And I divide that by 30. And I get negative 0.197 watt pounds per day. Okay, there you have it. I seem to have set down my notes, so I don't know exactly what. Oh, here it is. Okay, so how do they score that? 1 point. 1 point for that. Raise your hand if you got that. Anybody get it? Good. Okay, few people. Nice job. Way to work hard. Okay, we got part B. If you didn't get A, you can still get B. B says find the value of A prime of t. What does A prime of t mean? The derivative. Well, that's easy. How do I do that in my calculator? Number 6. What's my value? 15. That's it. Negative 0.164. Negative 0.164 what? Pounds per day. Not squared, because this is not the derivative of the derivative. This is simply a rate. It's the derivative of the amount, which will give us a rate. Now, the question is, what does that mean in context of the problem? Good statement, not entirely correct. We're still indicating an amount. We need to make a statement about rate. At time equals 15 days, the grass clippings are decaying We're decreasing at a rate of negative 0.164 pounds per day. That's what we want to say. At 15 days, exactly at 15, not 15 and a half, not at 15.5. We don't know the total amount of decay yet. We simply know at that time, it's decaying at that rate. So they give you 2 points for that, okay? 1 point for this, and then 1 point for the explanation. So this problem has a total of 3 so far. Part C. Part C says, find the time, T, for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin. So when the amount is equal to, what do we write for average amount? What is our formula for average amount? Integral from A to B, or 0 to 30 of the amount function. And then what has to go in front? 1 over b minus a, which is 1 over 30. When are those two things equal to each other? That's what we want to know. That's the equation setup. Can I figure this out? Yeah, I have that. It's sitting right here in my calculator. So how do I figure that out? What do I do? Good. Second calculate 7, lower limit, 0, upper limit. Very good. At the very end, I'll choose to multiply by 1 over 30. So what? Yeah. So I'm going to take this. Got to move to the side right there. So where is A of t equal to 1 over 30 times 82.579053? And so I got 82.5790, whoops, 53. And you can understand, I'm just carrying the decimals out so I can be as close as possible to that 3 decimal place. Divided by 30. So when is A of t equal to 2.7526351? So that's what we're trying to solve. What is A of t? Do we have an expression for it? What is the expression? That's what I want to figure out, right? That's a difficult expression right there. I mean, if you were asking me to solve that algebraically without a calculator, I really got no shot. There's 2 ways to solve this with your calculator. One is difficult, one is easy. That's the easy way. Does anybody know the difficult way? Logarithms. You could divide by the 6.87, take the log base, 0.931, so on and so forth. I would just encourage you to do this. Go into y equals. And what I do is I take my function and I'll subtract this over, right? So I'll go minus my 2.7526351. So now that I've subtracted that over, what is it equal to now? It's equal to 0. So what do I press on my calculator? So I can calculate 0. That's what we're trying to find. Does it cross the x-axis? Let's find that spot. So I can calculate what? 2? Or I already did that, didn't I? Left bound, enter. Right bound, enter. Yes? No. So we got t is equal to 12.415 what? What is time measured in this problem? Days. So how did they score that? They gave you 1 for the amount function, and then 1 for the final answer. I think that problem should be worth 3 in my opinion, but they just had to figure it out. So 1 for the amount function like that, 1 for the days. And last problem, D. I really, really, really like problem D. I mean, I really like it. And the AP exam really likes it too. You are going to get a problem like this. But this is about the first time we've seen it. So here's what it looks like. That's the graph, right? And it says that once you get to a certain amount of time, what day? What day? Yep, at 30 days, something happens. They said instead of looking at the curve, they say look at the linear approximation. That represents the linear approximation. Have we seen that kind of a drawing before? Just a line tangent to a curve, right? How do you find the equation for line tangent to a curve? What 2 things do we need? Slope and a point on the line. That's all. Anytime it says linear approximation, that's all it's asking. So find your slope, find your point on your line, write your y minus y1 is equal to m times x minus x1, and go to town. So what does the point on the line start with for the x value? 30. How do I find the y value? Yep, plug in the equation. I go back to my calculator. I remember I've got to get rid of that 2.75 thing now. And so as I calculate, I'm going to calculate a value number 1. And I'm going to plug in 30. And I get 0.782927787. What else do I need? How do I find that? Derivative. 6. 30. Once we have that, can we solve? We'll do that when you go get some brain food, okay? Okay, folks, we left off with this equation for a line, and let's solve it now. So we got our slope, we got our point on our line, and the question is, as we look back, the question says, use L of t right here to predict the time at which there will be 0.5 pounds of grass clippings remaining. Is 0.5 the x value or the y value? Y is the amount, x is the time. So we're going to take that 0.5 and simply plug it in for y. So as you look here, we have y minus y1 is 0.782927787 is equal to negative 0.0559762 times x minus 30. So all I did is I just plugged my values in for the equation of the line, and it says when is it going to have 0.5 pounds left? Because in our original equation, I used x and y here, but I very well could have just used t and amount of t, okay? So this is our x value, and this is our y value. So they're asking you, when do you have an amount of 0.5 left? And they're saying when. So when is the x value? The amount is the y value. Better? Okay, so we go 0.5 minus 0.782927787 is equal to negative 0.0559762 times x minus 30. Okay? I want to solve for x. What should I do? Yep, simplify the one side. So we got 0.5 minus 0.782927787. I get that. Now what should I do? Divide by negative 0.0559762. Now what? Add 30. We get 35.054. So that's worth 4 points. One for coming up with the linearization function. I think that they give you a point for coming up with the slope. I'm sorry, 2 points for the linearization function, and then 1 point for your answer, which is 35.054. Okay. Want to try an easier problem? Okay, flip it over. I think we had a total of that was the bottom one was 4, so we got a total of 9. We're gonna move to problem number 5. No calculator, no calculator. Okay. This one has table values instead of the function piece. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t is that. Given by this differentiable function up there, where t is measured in minutes, select the values of c of t measured in ounces are given in the table above. First things first, c of t, is that the amount or is that the rate? It's the amount. This is an amount function, not a rate function. Okay, that's the first thing we need to decide. So you understand the context of the problem. So it is an amount function. Second of all, what does it mean to be differentiable? It's continuous. Give me an example of something you couldn't take the derivative of. A corner, right? Or a vertical tangent, right? Or a discontinuous function. So if it's differentiable, it's not any of those. We know it's continuous. We know we can take the derivative at any point. That will come up later on to be very important. It says use the data in the table to approximate c prime of 3.5. What does c prime mean? The change, the derivative. How will I approximate that? I don't have a 3.5. C of 4 minus C of 3 divided by we are trying to do C prime of 3.5. So what I'm going to do to estimate that is I'm going to take C of 4 minus C of 3 divided by 4 minus 3. Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1. Raji! And that is approximately equal to C prime of 3.5. Okay? So, what is C of 4? 12.8. What is C of 3? Divided by 1. What is 12.8 minus 11.2? 1.6 what? We just found a rate. Ounces, good. Per minute. You get 2 points for that problem. 1 for 1.6 and then 1 for the ounces per minute. Everybody can get that type of a problem. Teachers. Yes, so as a teacher you can apply to be part of the AP scoring group, and so you fly to, I don't remember if it's Utah or where they do it, but and you sit down and for about 4 days straight for 6 hours you grade exams. You get paid for it, yeah, you get paid well. And they have a triple check system, so I would grade it, and somebody else would grade it, somebody else would grade it to make sure that we're being consistent all the way through. It's quite a process. Yep. It's an honor to be able to be part of that and do that. If we continue down this AP line for a number of years, I will probably look to actually be part of the scoring group. I'm pretty confident that I would do fine with it, but who knows? You apply. You would apply, and you know. Yeah, so once they see that I'm familiar with the test and I've gone to enough AP institutes and stuff like that, they would probably, they would probably allow me to do it. And if they see that you're not able to grade it correctly, like if somebody keeps on checking your mistakes, then they'll ask you to leave. So Yes, there's a point for label. So 2 points total, one for 1.6, one for the ounces. That I'm not sure. So I don't know the answer to all those questions because I haven't actually been part of the group yet. I'm just trying to remember what the lady told me when I went to the AP Institute. I don't think you would get, I think you get 1 point if you get the 1.6, and then you would get the additional point for the correct label. I don't think they're going to give you one just for the label. But I could be wrong. I don't know. All right, here we go. Part B. Is there a time t? This is the hardest question on here. Is there a time t between 2 and 4 for which c prime of t is equal to 2? Okay, you think that there could be. Again, it's not asking between 0 and 1. It's asking between 2 and 4. You say it could be. Can you explain a little bit more? Yeah, so what Allison's trying to picture here is that, who knows what the curve looks like, right? I mean, there might be a time where the slope is less than 2, but there might be a time where it's greater than 2 or equal to 2, all right? And so we can actually show that because we're told it's differentiable, we can actually find this amount. And I'll show you. We're going to do c of 4 minus c of 2 divided by 4 minus 2. What is c of 4? 12.8. What is c of 2? Take 4 over 2, which is 2. You remember something that we learned first semester that talked about this? F of b minus f of a over b minus a is equal to f prime of c for some c between a and b. Remember what that was called? The mean value theorem. And the mean value theorem says this. If you have a curve and we know that the average rate of change, so is say 2, we'll say that the average rate of change is 2. If it's differentiable and continuous, then there must be a spot somewhere on the curve where the slope is 2. So maybe say right there. And maybe say like right there. Are we okay with that? Those must exist. And so the answer to this problem is, it says, is there a time? The answer is yes. And then it says to justify the reason. The mean value theorem, MVT, what was the other one that we used? IVT, the intermediate value theorem, displays continuity. This tells us that there has to be a slope at some point. So the mean value theorem guarantees some t value for 2 less than or equal to t less than or equal to 4, such that c prime of t is equal to 2. So all I really did is I just took the original problem and restated it. It's asking right here, is there a time t between 2 and 4 such that c prime of t is equal to 2? Yes. The mean value theorem guarantees some t for t greater than 2 but less than 4 such that c prime is equal to 2. So you get 2 points here. 1 for answering yes. And you get 1 for then invoking the mean value theorem and stating that it is guaranteed. That's, I think, for most people, the hardest problem on here. Problem C, you're going to like a lot. Problem C says, use a midpoint sum with 3 subintervals of equal length indicated to approximate the value of 1 over 6 integral 0 to 6 of c of t dt. So 1 over 6, 0 to 6, c of t dt. How many subintervals am I creating? 3. Can you tell me, how do I make my first subinterval? I go from 0 to 2. Second subinterval, 2 to 4. Good. So where will I be evaluating the midpoints? 1, 3, and 5. All right? So here we go. This is equal to 1 over 6 times, what is the width of the first rectangle? 2 times, what's the first height? 5.3 plus 2 times 11.2 plus 2 times 13.8. So I get 1 over 6 times 2 times 5.3 is 10.6. 2 times 11.2 is 22.4. And 2 times 13.8 is 27.6. We add those up. 10.6 and 22.4 make 33 plus 27.6, 60.6. 1/6 of 60.6, 10.1 what? Ounces. Not per minute. And here's why. We'll explain it. The second part of question C says, use correct units and explain this meaning in context of the problem. We talked about it earlier, folks. What does this thing mean when we put the 1 over b minus a in front? Average amount. So look in the context of the problem, you guys. 10.1 ounces. Look at our original problem. Does it look like 10.1 would be approximately the average number of ounces in the coffee cup over that time? That's what it's stating. So that's what we need to say. 1 over 6, 0 to 6, C of t dt represents the average number of ounces in the large coffee cup. Am I done? Over the time, t equals 0, t equals 6. Again, I'll always remember that first time I got this part right, but I didn't state that correctly. Okay, so always say something about the bounds. Always state something about the bounds. The last problem is a nice problem that you guys will have success with this one. It says that we are now given a function. It says that the amount of coffee in the cup can be modeled by this function. Using this model, find the rate at which the amount of coffee in the cup is changing when t is equal to 5. What does rate at which the amount of coffee in the cup is changing mean? What does that mean? The derivative, yeah. So can you take the derivative of this? It looks difficult, but it's not bad. B of t is 16 minus 16e to the negative 0.4t. I need to find b prime of t. What's the derivative of 16? 0. So now I need to do the derivative of negative 16e to the negative 0.4t. This was on your final exam for the first semester. You know how to do it. What's the derivative of negative 0.4t? Negative 0.4. What's the derivative of negative 16e to the u? Negative 16e to the u. Okay, multiply negative 16 times negative 0.4. 6 6.4. E to the negative 0.4t. So the derivative is 6.4 e to the negative 0.4t. And we are trying to identify it at what time? 5. If I plug in 5, what is negative 0.4 times 5? Negative 2. So 6.4 over e squared. What is my label? I'm looking for a rate. Ounces. They give you 2 points here. It's like they give you 1 point for the derivative, give you 1 point for the answer. The previous problem, they give you 1 point for setting up the appropriate sum, 1 point for the 10.1 ounces, and 1 point for setting up the credit integral and stating what it means right there. Okay, so here's what you are going to do today. I can't remember because I erased it. So let's look at what I wrote online. AP Calculus. And we are at the calendar. That's our calendar. 4 and 8. We scored problem 3 today. We did problem 5 in class. 4 and 8. I asked the second hour, and they didn't really have a good response. My question was, would you like me to show you how to do them 4 and 8 on Monday? Or would you like me to have you score these on your own and show 2 different? Only one person spoke up, and they said, let us score these on our own and show us 2 different. That way we see more problems. I just didn't know, is it more helpful when you try it on your own and I show you how it's scored, or if you do it on your own? So I guess if you have strong feelings one way, then I'll prepare accordingly. So. Like that better? Okay, so then I will score 4 and 8 with you in class, but then I won't be showing you new ones because it'll take us that time to do 2 problems. So, okay, so then you'll get 2 problems that night, and then you'll score those on your own. Okay, so that will be the deal then, okay? All right, and like I said, we're spending 3 days on these because these are a little bit more involved, okay? But at least you're going to have a fighting chance when you see these type of problems. On Monday, I haven't decided yet. I got to look ahead. There's a lot of problems to choose from on this section.